All right, so these are the nodes for quadratic applications with graphing, all right? So it says to analyze the situations involving quadratic functions, formulate a quadratic equation, then solve the problem. So complete the information for the given rectangle. So we have the width and the length. It says write a function for the area in terms of the width w. So we know that the area is length times width, so w times w plus 6. So notice this is in terms of w, so I'm going to write a of w. You can put y, it's fine. W times w is w squared. W times 6 is 6w. So now we see we have it in standard form. And it says to create a table for the function. All right, so usually we're going to have to find the vertex. So you notice on part C, there's stuff I can actually do here. So let's go to identify what we know. We see w squared, so we know that a is equal to 1. B is 6w, so it's just 6. And we can see that C is 0 because there's no C value. So I'm going to work out my information here. So for the axis symmetry, it's x equals the opposite of b divided by 2a. So x equals the opposite of b is negative 6 divided by 2 times a. So that's going to be negative 3. So we now know that x is equal to negative 3 from axis symmetry. We also know that this is the x value of the vertex. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So we know this goes in the middle. Now to find the remaining vertex, we just plug this number into the equation. So negative 3 squared plus 6 times negative 3. So negative 3 squared is 9. 6 times negative 3 is negative 18. So 9 minus 18 is negative 9. And then from here, we're going to go numbers that are bigger. So negative 3, negative 2, negative 1, 0, 1, and then smaller, negative 4, negative 5, negative 6, and a negative 7. For me, I'm just going to use the 1, 3, 5, 7. So from here, I'll add 1, then add 3, add 5, add 7. So that's the 1, 3, 5, 7. So negative 1 plus 9 is negative 8. Negative 8 plus 3 is negative 5. Negative 5 plus 5 is 0, and then 7. And I know it's going to be a reflection over here. And there is my table. So notice this is my vertex. I can see my x-intercepts right here, because that's where y is 0. All right, so over here, for the second part, we're going to graph this in a moment, but we have the vertex, we have the axis symmetry, the direction, which way is it opening? Well, we can tell from here that the a value is positive 1, so we know that our direction is up. And we actually solved the roots here, right? The roots are x-intercepts, so our first one was at negative 6, 0, and our second one was at 0, 0. So those are my two roots. Now, it does say to graph the function and determine this, which we determined this. We're going to graph the function. Now, you notice it starts pretty much in the first quadrant, right? This is the y-axis, or sorry, the x-axis. X and y-axis, and it starts in the first quadrant. So the only point I can use is 0 and 1, 7. So it's there, and I'll put it closer. And then we just draw our sketch going up, and there we go. All right, so it says to determine a reasonable domain and range that represents the situation. So notice when I do this graph, I didn't draw all this other stuff over here. I started at 0, 0, and notice I put an open circle, which means it's not included. But 1, 7 is a closed circle, which means it is included. So, so what this means is, you know, a width of 0 and an area of 0 doesn't exist. I mean, that's why it's an open circle, because there's nothing there. But past that point, everything would be included. Now, all these negative values I got rid of because you can't have a negative width. We've talked about a lot of problems where you can't have a negative width or length, and you can't have these. And plus, some of them create area that's negative as well. So a reasonable domain from left to right would be 0 to infinity. And notice 0 would not be included because it doesn't represent anything. And the range would be the same thing, 0 headed towards infinity. All right, from here, we go to number 2. It says the length of a rectangle is 3 feet more than twice the width. Write the function of the area in terms of the width. So we can call this the width. and it says the length is twice the width and 3 feet more. So twice the width and more 3 feet, so plus 3. So there is my width and my length. So to find the area, it's going to be W times 2W plus 3. So write the function of the area in terms of the width W. So A of W equals W times 2W is 2W squared. W times 3 is 3W. Alright, and once again, we're going to use this one. It says, if the area of the rectangle is 14 feet squared, find the dimensions. So this 14 is going to go in for the area right there. So 2W squared plus 3W is going to equal to 14. So we're going to solve this. So we're going to go ahead and move the 14 back to the same side as the other terms. And then we're going to attempt to factor this. Now, if factoring didn't work, I would then use the quadratic formula. But let's go ahead and try the x method here. So we have b is 3, a is 2, and then 2 times negative 14 is negative 28. So my two factors that add to 3 and multiply to negative 28 are going to be, let's see, 7 and 4. And that would be 7 minus 4. So 7 halves doesn't reduce, so that's going to be 2, and that's w, plus 7. And negative 4 over 2 reduces to negative 2, which is going to be w minus 2 is equal to 0. Set each one equal to 0 and solve. So for this one, add the 2, w is equal to 2. This one, I'm going to solve it because I don't want to run out of space here. I'm going to subtract the 7. And then I'm going to divide by 2, and w equals negative 7 halves. So I have two answers right here, but only one of them can be correct because we know we cannot have a negative width. So my actual width is going to be 2, and the units is feet squared, so it's going to be 2 feet. Okay. From here, it says to find the length. Well, we know the length is twice the width plus 3, so length equals twice the width, so twice 2 plus 3. So 2 times 2 is 4, 4 plus 3 is 7 feet. And then last, it says to find the perimeter, which means we just add up all the sides. So we know the lengths are 7 and 7, which is 14. This is 2 and 2, so 14, 15, 16, 17, 18 feet. And it's not squared because it's perimeter, not area. All right, on to the next one, number 3 right here. It is a triangle here. It says the following triangle has a height of 2x and a base of x plus 5. Find the function of the area in terms of x. So if you recall, the area is base times height divided by 2. So for this one here, we're going to say in terms of x, so a of x equals the base times the height divided by 2. And hopefully you see you can reduce the 2's here to 1. So now I have x times x plus 5, so x times x is x squared, x times 5 is 5x. And there is my function now for area. So let's write it nicer so we can see it. A of x equals x squared plus 5x. And I'll box that in so you see that that is my equation. All right, from here, it says if the area of the triangle is 36 centimeters squared, find the height and base. So we're just going to plug this, like the previous one, in for the area. So x squared plus 5x equals to 36. We're going to go ahead and subtract 36 over to the same side, so that it does equal 0. And then we're going to attempt to factor it. And if not, then we will do the quadratic formula. So x method. 5 on the top, 1 times negative 36 is negative 36, divided by 1. So 9 minus 4, so it's going to be x plus 9, x minus 4, set each one equal to 0. So for this one, we subtract 9 from both sides, and x equals to negative 9. Add 4 to both sides for the second one, and x equals to 4. And the correct answer here is going to be the 4, because that's positive. Can't have negative height x. So it says if the area of the triangle is 36, find the height and the base. So for the height, we know the equation is 2x, which is 2 times 4, which is 8. So that's going to be 8 feet. For the base, we know it's x plus 5, which is 4 plus 5, which is 9. So 9 feet. All right, let's go ahead and keep going here. Find the height and that. Okay, let's keep going. Number 4. It says, as an arrow is shot upward, the height of the arrow is determined by h of t equals 64t minus 8t squared, where t is the time in seconds and h is the height in feet. What is the height of the arrow at 3 seconds? So for this type of problem, you can plug it into the calculator, but at the same time, hopefully you see that this is 3 seconds, which is time. So what I actually could do is just take h of t and set it equal to this, so 64 times 3 minus 3 squared, and I could put that in a calculator. The same thing with 6 seconds, h of t equals 64 times 6 now, minus 8 times 6 squared. Alright, so I do have this Desmos calculator here, and I'm just going to do this real quick. 64 times 3 minus 8 times 3 squared. So that looks like it's 120 feet. And for the other one, let's see what we can do. It's going to change to 6. Which gives us 96 feet. Another thing you could have done was just type it in. So we have, we'll change this to y next. So y equals 64x minus 8x squared. Alright, so you notice I do have this here. So my first question was, what is the height at 3 seconds? So that's, what's the height? 3, x equals 3. And I can see right here, I'm going to find where they intersect. So if I click it, the height, 3 seconds, 120 feet. And the second one said, what about at 6 seconds? So I can say x is equal to 6. And let's see, we have here, so we're looking at the purple line where they intersect. And we can see right there, it is 96 feet. So right there, 96 feet. So notice I put in x equals, not y equals, because x is the time and y is the height. So it gave me times, that's why I put x equals. So hopefully you can see those two answers that I got by using the graph. All right, now I'm going to probably use the graph to solve the rest of this. It says, how long did it take the arrow to reach its maximum height? So pretty much it's asking me to find the vertex here. So let's go ahead and close these out here. So let's go ahead and click on the vertex, and we can see it is 4, 128. Now I could also just find the vertex by doing the opposite of b over 2a, but since I do have this graph, I'm going to use it. So 4, 128 is a vertex. So how long did it take the arrow to reach its maximum height? Well, it took x value of 4 seconds. Don't forget your units. What is the maximum height? Well, the maximum height reached is 128 feet. When did the arrow hit the ground? So what that's asking me for there is the x-intercept, not the first one, but the second one. So as we scroll down, we click right here, and we see that it took 8 seconds for the, is it the rocket? An arrow to shoot upwards and hit the ground. So it took 8 seconds. And determine a reasonable domain and range that represents the situation. Well, the domain is pretty easy because we're already right here. It started at, it's the roots, right? It started at 0 and it stopped at 8. So my domain would be 0, 8, and I'm going to include both of those values. And for my range, we know it starts at 0 and then it reached the maximum height, if you recall, 128 feet. So 0, 128, both in brackets there. All right, and let's take a look at number 5 and 6. It says, write the equation of a parabola in vertex form, and here it is right here. So we have to identify A, H, and K. So a vertex at the origin, which means we have 0, 0, which is H and K, and it opens down. So the A value is a -1, or a negative sign, right? So right here, we start with y equals. A was negative. We don't have an H, so we plug in 0 there. It's x minus 0, 0, so that's x squared. And we don't have a K value because that was also 0, so my equation is just y equals -x squared. For number 6, it says a vertex at -4 and 1, so this is H and this is K, and a vertical stretch factor of 1, which doesn't change anything, so A is just 1, so we don't really need that. So let's go and start. Y equals A is 1. I'm not going to substitute that in. X minus H. So when I plug in the -4, it looks like +4. Squared, and then positive K, so that's +1. And that's how you write the equations in the parabolas in vertex format. And that concludes the notes.